Right, hello again, welcome back. What I want to do is to look at the neutral current calculations format. And all I've done here is to give you a simple example of how to calculate the current in the neutral conductor. Now, I've simply started here with a capacitor and what the purpose of a capacitor is used for in the circuit. Purpose of a capacitor in a circuit is corrects the power factor such that it brings the power factor close to unity, which is 1. Okay. Neutral current calculations. And all I'm doing here is giving you an example as to how to approach this. By all means, this is not the only example. Okay. Now, here we're looking at where A and B and C are the free phase currents. The formula to find the neutral current is the square root of the following. So here we will have A squared B plus B squared plus C squared. Okay. Now here I'm assuming that the value of A is 5, the value of B is 8, and the value of C is 10. Now bear in mind that is minus AB, minus AC, minus BC. Okay. Now I do have a little question for myself on this, but I might get back to that a little bit later, after I've checked out a little bit more information for myself. Now remember, when all currents are balanced in a three-phase circuit, no current flows in the neutral conductor. Okay, and it's worth bearing that in mind. Okay. Now, following on from the information given previously, in respect of the formulas, we need to square the values given. Now I've just mentioned the values to you, okay? So please use those values in part. So here we have 5 squared, 8 squared, and 10 squared. I've simply said here these values are squared, okay? Now, if you square 5, it becomes 25. Okay? So square 8, 64. Okay? And 10 squared is 100. Now we now need to apply the formulas as previously given. And all I've done here is to repeat the A squared plus B squared plus C squared minus etc, etc, etc. Now taking those values into account, when you add 5 squared, 8 squared and 10 squared, it comes to 189. Look at the formula as it stands: A times B minus A times C minus B times C. Now I do have a little question about that for myself, but I will look at that a little bit later when I do a little bit more research into my own question. But taking that into account, 5 times 8 is 40, 5 times 10 is 50, 8 times 10 is 80. Okay. Now if you then subtract, when you add those together, it comes to 170. If you then subtract 170 from 189, it will leave you 19. Okay. Now you then need to find the square root of 19. And as you find the square root of 19, you'll find that it comes out to 4.36 amps. Okay? And that is the current in the neutral in this case. That is not always the case in this case, purely as an example. Okay? Now this is an example of how to calculate the current in the neutral conductor. In this case, the current in the neutral is 4.36 amps. Now also the line conductors would be given L1, L2 and L3. Okay? And there are some examples I have of these, but I may put that on a little bit later. Okay, but please remember that you can begin to look up more calculations in regards to electrical principles. There's some good books on that as well, showing the calculations for the current in the neutral. It's also part of the 2357, okay, at level 3, where you're required to calculate the current in the neutral conductors in regards to three-phase supply. Okay. Alright, that will be it for now. Thank you. And again, have a good evening, and thanks.